I'm Niranjan. I'm from 3C Batch 1. Here I have made a project for hackathon related embedded system. This is an automatic braking system car. So while driving car, if drivers get a distraction of just 1 second, and a vehicle or an animal can come in front of the vehicle and make a major disaster. So to prevent this, I have made an automatic braking system. So I have used Raspberry Pi Pico, Raspberry Pi Pico motor driver, ultrasonic sensor, gear motors, and power bank, 12-volt power supply. So we need a motor driver because if we connect the motor directly to the Raspberry Pi Pico, our board might get damaged because the motors need a more voltage like 5 volt or 9 volt, but the Raspberry Pi Pico only can provide up to 3.3 volts. So I have used a motor driver. This gets the power from the power socket, and it gives enough power which we can set in the code to the motors. And it has 4 input pins and 2 PWM pins. PWM pins stand for pulse width modulation. This widens the pulse of electricity and controls the speed. The speed we can set in the code. So the input 1, 2, 3 and 4 are connected to GPIO 11, 12, 13, 14 respectively, and the 2 PWM pins are connected to GP10 and GP15 respectively, and the VCC of the ultrasonic sensor is connected to VBus, and the trigger is connected to GP0, and echo is connected to GP1, and the ground is connected to the ground of the Raspberry Pi Pico. So let us and I have connected a female DC jack with the motor driver, and I have also this female DC jack is to connect this 12 volt power supply. Then let me show you the code. So this is the code for my project. First, I have imported required libraries such as machine, time, time. So next, I have declared the pin of the ultrasonic sensor, and I have declared the pin of motor L298 and motor driver. So this M1 and M2 is for the 2 PWM pins, and I have set the frequency. So next, I have defined some functions. So to stop the motor when an object is detected, I have defined a function called motor stop. In this, I have defined that if the motor stop means the 2 motors should be off, and the PWM should be value should be 0. And in the function motor forward, I have defined that the 2 motors should run in clockwise in same direction, and the PWM should be selective according to us. Then I have created a while loop, and this code is to trigger the ultrasonic sensor, and this is the calculation to find the distance between the sensor and the object. So 0.0343 is the sound speed of the sound, and the duration is the like the time between the ultrasonic sensor and the object. So as you know, distance is equal to speed into time. We get the object distance. So next we have the automatic braking system, which is the main code. If an object comes in between and it is less than 10 cm, the motor should stop, and I gave a print command to check whether it's working. If this condition is false, the motor should go forward. I have set the speed as 14,000. So this is the code. Let's see the project working. So here I have connected this motor driver to a power supply, and to give power, I have connected a power bank to the Raspberry Pi Pico. Okay, let me turn on the switch and the car will move. So I have also kept an obstacle over there. If when it reaches near it, it will just stop. So let me turn on this power, it will move. So as you see, when it comes near the obstacle, it stops. So let me remove this obstacle. So it's going. As you saw this project, the car automatically stopped when it is near to the obstacle. So if you ask that if this can be directly implemented in a car, no. As you saw, when it detected the obstacle, it suddenly stopped. So it can cause injuries to the people who are inside the car also. So if it is implemented in real life, it should be properly, like when it is detected an obstacle, it should slowly reduce the speed. Nowadays, this automatic braking system known as ABS is also used in some cars which have the ADAS. ADAS means Automatic Driving Assistance System. These are applied only in some of the cars, and they use almost this principle. Thank you.